Scatter gather approach. What is the meaning of scatter gather approach? Consider all of these items which are already stored in the bucket is in the sorted format. All of these things are in the range of 0 to 5. If it is uniformly distributed, we state that it is the best case. Hello everyone, it is Dr. Ravi Kumar Vaibi. Today we shall see the sorting technique, one of the sorting technique, that is bucket sort algorithm, which is available in the first unit of your syllabus, that is bucket sort. In this bucket sort, you will come across different groups of information. What is the meaning of groups of information? Let me tell you that. A bucket sort is a sorting technique that allows you to group the unsorted array of elements. I am using the word group or combine the elements of an array into one single group called bucket. On which basis you are going to group or combine the elements into one single group, that is also a matter here. This is a sorting technique that divides the entire unsorted array of elements into small groups. Small groups in the sense, if I have the elements varying from 10 to 100, if the elements are sorted from 10 to 100, that has to be sorted and grouped into one single buckets, that is varying from 10 to 19, it is closed into first bucket, 20 to 29 is placed into second bucket, 30 to 39 is placed in third bucket, so on up to 90 to 99 is placed in 10th bucket. The last element, that is 100th element, is placed in 11th bucket. So totally how many buckets are there? 1 to 11 buckets are there. Within each of these buckets, that is each bucket is then sorted by using any of the suitable sorting algorithm, whether it may be an insertion sort, or it may be a bubble sort, or it may be a selection sort, or it may be a quick sort, or any of these sorting techniques. We are going to employ any of these sorting techniques into one single bucket, into each of these single buckets. So by doing this, the elements in each of the buckets are already in the sorted form, so that the elements are scattered as it is into different forms in the one single array, so that the elements in the single array will be in sorted format. The same thing is applied here. Finally, the sorted buckets are combined to form a final sorted array. So let me explain you with an example in the next few slides. In this case, scatter gather approach. What is the meaning of scatter gather approach? First, we are going to gather all the elements into one group called bucket. Once the elements are sorted perfectly in each of the buckets, we are going to scatter the elements into different positions according to their increasing order of their bucket numbers. That is called as scatter and gather approach. The same thing is applied here. If you look at this example, it is very much clear that we have the first element, that is 11 is greater than 9 and 9 is less than 21, 8, 17, 19, 13, 1, 24, 12. This is in random order. This is in random order. Suppose if I consider this as 0th, 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th. So totally 0 to 9, 10 items are there. So totally 10 items are there. In this case, we are going to consider 0 to 5 as the items to be inserted into one of the buckets. Then in this case, 5 to 10 is another range of elements which is inserted into the next bucket. So this is called as a first bucket, second bucket. 10 to 15 is inserted into third bucket. 15 to 20 is inserted into fourth bucket. 20 to 25 is inserted into fifth bucket. So totally we have 5 buckets here, where each of these buckets can hold the values varying from 0 to 5 of elements. In each of these cases, in this example, we have the elements varying from 1 to 19 or 24. 1 to 24. So if that is the case, 0 to 5 comes into bucket 1, 5 to 10 comes into the next bucket, second bucket, then 10 to 15 comes into third bucket, 15 to 20 goes into fourth bucket, 20 to 25 goes into fifth bucket. So totally we have these items in different buckets. So if that is the case, what is the term I am going to do now? So 1 is the item which is between 0 and 5. So let me place it in the first bucket 1. Next we have 5 to 10, which are the elements ranging from 5 to 10, 8, 9, that's all. So let me place the elements. 9 is in the order first, then 8. Then 10 to 15, which are the items available between the range of 10 to 15? 9, 11, then 12, then we have 13 here, then we have, that's all. These are the 3 items we have in the third bucket. In the fourth bucket, we have ranging from 15 to 20. 16 do we have? No. 17, yes we have. 19 we have. So 17 and 19 we have in the same order. So finally in the fifth bucket we have 20 to 25. So between 20 to 25 we have 21 and 24 in the same order. Let me keep it in the same order, that is 21 and 24. So in this case we have 5 different buckets here, and let me consider any of the quicksort algorithm or any of the insertion sort algorithm. Then by employing those quicksort algorithm or any of the sorting techniques, we will get the elements sorted within each of these buckets. If that is the case, 1 is placed in the first bucket, 8 and 9 are placed in the second bucket after sorting technique. Then 11, 12, 13 is in another bucket. 17 and 19 in another bucket. 21 and 24 in another bucket. So if that is the case, I can consider all of these items which are already stored in the bucket is in the sorted format. So let me combine and scatter all these elements into the array. That is 1, 8, 9, then 11, 12, 13, 17, 19, 21, 24. So at the end of this, we will get an array of items which is in the sorted format. So by doing this scatter and gather approach, we will get the elements sorted in the final array. So the same thing is obtained here: 1, 8, 9, 11, 12, 13, 17, 19, 21, 24. So it is the final array which is in the sorted format. So if that is the case, suppose if I consider the floating point type of values, in this case we have the decimal point as well as the fractional part and decimal part. We have decimal part, fractional part, decimal point. All of these are called as a floating point values. Floating point values. Let me create an array of size 10. If that is the case, 10 is the size of an array, and what is the value I am going to insert into it? And if I consider 0 to 5 as one range, that is, in this case, all of these things are in the range of 0 to 5. Let me consider 0 to 5 or 0 to 2 here. Right. If that is the case, see here, what is the size of an array I am defining here? It is 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0 to 9. So totally we have 10 items here. So if that is the case, if there are 10 items here, then we have to place these items into this array after gathering. So how we are going to gather the elements into a bucket? That is a topic of interest now. So if that is the case, so 10 is the size of an array. This has to be size of an array must be multiplied with the numbers. Which is the number that is available there? 0.42. 0.42. 42 indicates that it is equal to 4.2. That is, the first item is 4.2. 4.2. Which is the next item? 0.32. Then 10 into 0.32 is equal to 3.2. So let me have 3.2 now. 0.23. 10 into 0.23, that is 2.3. 2.3. 0.52 into 10 results to 5.2, that is 5.2. 0.25 into 10 leads to 2.5. 0.47 leads to 4.7. 0.51 leads to 5.1. So if I take the elements floor of this, what happens? What is the floor of this? That is 4.2. The floor of this is equal to 4. The floor of this is equal to 3. The floor of this is equal to 2. The floor of this is equal to 5. So if that is the case, I will be having one more array with the floor of those. What is that floor of that? 4, 3, 2, 5, 2, 4, 5. So if that is the case, we have the elements in this order. So in the same manner, what has to be done now? So we have to gather the elements. How we are going to gather the elements? For floating point type of data items, especially for floating point type of data items, that is a topic of interest now. So if you look at this, insert the elements into the buckets from the array. The elements are inserted according to the range of the buckets. That is, in our code, the range is from 0 to 1 into one bucket, 1 to 2 into another bucket, 2 to 3 in another bucket, so on up to n minus 1 to n into another bucket. So if that is the case, 10 is the size of an array which is initialized to 0 initially. Now 0.23 into 10 leads to 2.3. Then it is converted into an integer, that is 2. Finally 0.23 is inserted into bucket 2, that is bucket number 2. So if that is the case, which defines the bucket number? So the bucket numbers are notified here. If that is the case, we have the buckets which is having the first bucket which is having empty, the second bucket which is having two data items. Which are those two data items? 0, 1, 2 and 5. 0.23 and 0.25. 0.23 and 0.25. Right? Which is the item next which is having in the third bucket? That is the second item, 0.32. Which is the item that is having the fourth value? That is 4, last but one, that is 0.47. Which is the element having that? This one, 0.51 and 0.52. Let me keep it in the same order. 0.52 and 0.51. So if that is the case, let me have the quicksort algorithm to each of these buckets. If I apply the quicksort algorithm to each of the buckets, since the first bucket is having the value which is empty, there is nothing in the first bucket. In the second bucket we have 2 data items. In the third bucket we have 1 data item. In the fourth bucket we have 1 data item. In the fifth bucket we have 2 data items. If that is the case, let me employ the quicksort algorithm on each of the buckets so that it can be scattered into the part of an array which is having the size of 10. That is, from here to here we are going to scatter that. How we are going to scatter? Let me show you that. 0, 1, 2, that is, we have here from here I am going to consider 0, 1, 2, that is 0, 1, 2, 3, 4, that is totally 5, and let me have one more bucket varying from 0 to 1. This is from 1 to 2, this is from 2 to 3, 3 to 4, 4 to 5, 5 to 6, so on like that. If that is the case, 2 to 3, that is, this bucket is having 2 data items, 0, 1, 2, that is 0.23 and 0.25. 0, 1, 2, 0.23 and 0.25 are the 2 data items available in the second bucket. In the third bucket we have only 1 item, that is this item, 0.32. Then 0.47. Then we have 0.52 and 0.51. 0.52 and 0.51. So if this is the case, we have the items in this order. So if you look at this diagram, it is clearly representing that values 0.23 and 0.25 are placed in the second bucket. So the same manner we have applied here. Now we have to scatter these elements into different positions. If that is the case, it is sorted into 0.23, 0.25, 0.32, 0.47. It has to be in the form of, please be careful here, it has to be in the form of 0.51 and 0.52. That is, in each of these buckets, it has to be sorted. The elements must be sorted. Then it is scattered. It is scattered. That is, into the 0th position we have 0.23. In the first position we have 0.25. In the second position we have 0.32. In the third position we have 0.45, 47. In the fourth position we have 0.51. In the fifth position we have 0.52. So we have these data items. Let me consider the same information in the next and subsequent slides. See here, this is 0.23 in this, 0.52 and 51 in this. It is not yet sorted. It has to be sorted. If it is sorted, that this value becomes 0.51 and 0.52. So totally it turns out to be 0.51 and 0.52 if it is sorted. So next we have the items 0.51 and 0.52 which is sorted. So we have the items here 0.47, and there is one more item which is missed out, that is 0.42. That is 0.42 here. It is already sorted. So let me keep this into this. term 0.42. If that is the case, we will get the items in this array into this form: 0.23, 0.25, 0.32, 0.42, 0.47, 0.51, 0.52. So totally we have the elements varying from this 0.23 to 0.52. 1, 2, 3, 4, 5, 6, 7. So totally we have 7 data items here. So you can see to it here, that is 0.42 and 747 is already sorted. It is not sorted, so it has to be sorted. If it is sorted, that turns out to be the value 0.51 and 0.52 in this location. Then finally we will get the items in the sorted format in this. Sort the elements in each of these buckets. So totally that turns out to be this format. Then finally we will scatter it into different locations. That is 0.23 is pushed into this position, 25 is pushed into this position, 32 into this position, 42 into this position, 47 is remains in the same position, 51 in the same position, 52 in this position. So 0 to 6. So totally we have 7 data items. The same thing you are going to find out in the next slide. That is in this slide. So 0.23 and 25 is considered here, 0.32, 0.42 and 47 is considered here, 0.51 and 0.52 is considered here. So totally that turns out to be 0.23, 0.25, 0.32, 0.42, 0.47, 0.51 and 0.52. So each of these elements have been scattered into different locations, and the last few data items which are supposed to be placed here remains empty, because since it is empty, I can delete it and keep the data items which is non-zero in this array and place it as a form of a sorted array. The same thing applies to various other types of algorithms. Initially, we discussed about the integer type of data items, which was supposed to be sorted using the bucket sort algorithm, and we have studied another type of option, that is floating point type of data items, wherein the data items have been sorted into different data positions with these data items. So we are going to employ this bucket sort algorithm to sort both integer type of data item as well as the floating point type of data item. Then what is the advantage of that? The same thing. You can sort either floating point type of data item or an integer type of data item. It works on both. So if that is the case, let me consider the algorithm for bucket sort. In this bucket sort, let me create the buckets initially, n number of buckets, where each of which can hold a range of values, that is varying from 0 to 5, 5 to 10, 10 to 15 are the range of values or interval of values in which you are going to find out the items within that range in some buckets. And once when the quick sort is applied, for all the buckets, initialize each of buckets with 0 values. For all the buckets, sort the elements in each bucket using any of the sorting techniques. Sorting technique within another sorting technique. That is, you can employ any of the quick sort, merge sort, heap sort, or any of the sorting techniques that you wish to employ can do it. Once it is sorted, you can scatter it into different positions. That is the definition of that. So we are initializing it into the bucket which is having 0. Nothing is there. So we are initializing it into an array like this. Then we are going to consider the range of elements where I is varying from 0 to range of, that is the length of an array. Suppose if it is a length of an array varying from 7, so total number of elements in the array was 7 earlier. So 0 to 7 indicates, so it considers only 0 to 6. Since it is 7, Python considers only 6 items. So 7 minus 1, that is equal to 6. So 0 to 6 data items are considered here and entered here. So bucket.append of this function is inserted here, because we have to append the data items which needs to be inserted at the end of the list. So we are going to use the append function here. Then for j in array, we are going to consider int of 10 star j. That is the size of the array. Initially we have, that is 10 star j, bucket of index b dot append of j. Then we are going to apply the sorted element by applying this sorted algorithm. So totally we are going to get the elements initially of this format, that is, which is not in sorted format. Once that is printed, that is bucket of sorted array, you will get the elements, that is 0.32, 0.33, 0.37, 0.42, 0.51, 0.57, not 57, it is 52. So totally we will get the elements printed in this order in case of bucket sort. Suppose if I reverse the function here, that is how I am going to reverse here. So let me have the comparison operator here. Let me have the comparison operator sorted of bucket, get the sorted items. This is called scattering. This part is called scattering. This part of the bucket is called as sorting or gathering. Gather and sort. Then sorted of bucket. If that is the case, which is the sorted bucket I am going to consider? Any of the techniques like quick sort, merge sort, heap sort, selection sort, bubble sort, or any of the sorting techniques can be used inside the sorting technique to sort the elements in each of the buckets. So next, what is the time complexity of the bucket sort? If that is the case, we have three strategies. One is the best case, and other one is worst case, and the third one is average case. These are the three different types of criteria we consider for time complexity. With respect to space, we are going to consider the space complexity here. What is the time complexity? What is the time required to execute the bucket sort algorithm in the best case? When it is called as a best case, let me consider that option. In case of best case algorithm, elements are uniformly distributed. When the elements are uniformly distributed and already sorted in each of the buckets, we can just scatter it into different positions, and we state that the number of time required is represented in terms of big O of n and big O of k, where n indicates the size and k indicates the time, and the element size into time that requires equal to 0 plus n, 0 big O of n plus k. This is the best case time complexity. Then what about the worst case time complexity? If I use the bubble sort, it takes n squared time, obviously. So when it is considered as a worst case, if the elements are randomly distributed, if it is uniformly distributed, we state that it is the best case. It requires 0 big O of n plus k time. If it is randomly distributed, it has to be pushed into different groups or into the different buckets, and it has to be sorted using any of the sorting techniques within the another sorting technique, that is bucket sort. We are going to employ a selection sort or bubble sort. If bubble sort is employed, we require n square time complexity. So the worst case time complexity of the bucket sort depends on the sorting technique we employ within each of the buckets. So if that is the case, we have used bubble sort here or quick sort here. So the worst case time complexity of this is bucket sort is big O of n square. Obviously, this is big O of n square. Then what is the average case time complexity? Average case time complexity is very, very crucial here, wherein few of the buckets are empty and few of the buckets are full. So in such cases, we will face the problem of sorting only few of the buckets and leaving other buckets ignored. That forms another type of problem that is called as an average case time complexity. Again, the average time complexity requires big O of n. Big O of n time complexity. Then what is the space complexity? The space complexity is if there are n data items free data items present in an array, it is requiring the total number of items present in each of the buckets must be concatenated into the single array. That is, it has to be scattered into a single array. That is called as big O of n plus k. What is the stability? Yes, we are going to get some stability while executing the different for loops or while loops within a sorting technique algorithm. So that is what you are going to see. Let me explain the average case, best case and worst case time complexity in more detail. In this case, we have the worst case time complexity, that is big O of n square. Since we are using the another sorting technique within the bucket sort algorithm, whether it may be a quick sort or a selection sort or a bubble sort, that requires the sorting time of big O of n square. In this case, the complexity becomes even worse when the elements are in reverse order. When they are in decreasing order, we have to sort it in increasing order, then it becomes very worse. Which is the other option we have? The time complexity depends on the sorting algorithm we are going to use. That is, if we use the selection sort or merge sort or quick sort or heap sort or bubble sort or any of this sorting technique within another sorting technique, that defines the worst case of that. The same thing was explained in the previous slide. Then, when there are elements of close range in the array, they are likely to be placed in the same bucket. So, few of the buckets are filled and few of the buckets remains empty. So, that is also another important problem of worst case. This worst case time complexity requires big O of n square time for this. Then, what is the best case then? Big O of n plus k. If that is the case, this occurs when the elements are uniformly distributed. When they are uniformly distributed, we will be having 2 items in one bucket, 2 items in next bucket, 2 items in next bucket, 2 items in another bucket. So totally we have equal number of items in each of these buckets. That does not pose any problem to me while sorting the items in each of these buckets. So if that is the case, we are going to find out they are uniformly distributed. So obviously that takes big O of n plus k time. So then we have average case time complexity. In case of this average case time complexity, we will be having the randomly distributed data items in an array or in each of the buckets. So that poses certain problems while sorting the items in each of the buckets. So it requires big O of n. So if you have seen through the bucket sort algorithm, a bucket sort is a sorting technique algorithm that requires another sorting technique algorithm to sort the items in each of the buckets or in each of the groups. So the time complexity of the bucket sort algorithm depends on the type of sorting technique we employ in each of these buckets. That is the drawback of this bucket sort algorithm. So if you have come across any questions, you may ask me the questions in the live sessions. Thank you all. Thank you very much.